Guys, so today I'm going to share with you a pretty nice and interesting case that some of you may have encountered, an experiment that I would like to try. I'm going to see if I can try. So let's get into it. Now, why am I being so mysterious? I'm sorry for that, but let me give you a bit of context first and foremost. So the other day I was investigating a bug at my company that had to do with the timeout issue on one of our systems. Me and my coworkers had kind of been struggling with this for a little while, and we had this unexplained issue where a certain percentage of our network calls to one of the subsystems was failing basically. And we couldn't really figure out why, because unfortunately we're in this situation where when you have a fairly large application, you basically have a bunch of layers where something could go wrong. It can go wrong at the network layer, it can go wrong at the proxy, at the load balancer, at the application, at the database and so forth. So when it comes to timeouts like that, it's actually really tricky sometimes to figure out who is the culprit. I mean, who is causing the network issue, or rather the timeout. So we were looking at it, and we're on top of that, of course, making an external call on as part of this request. And finally, one of my coworkers sat down and said, all right, I'm just going to look at the memory and let's just see how it works. Now, we are using Scala, and some of the seniors may now kind of suspect what the issue here is, because the call that is being made is causing a fairly heavy computation. Said and done, we did a little bit of an investigation, had a look at, all right, how does the memory allocation look? And what was beautiful was that the shark tooths, as you will see in a JVM-based memory system, kind of coincided with the 20 roughly seconds of downtime these requests were facing. In other words, the timeouting was kind of connected to the drop in memory, which of course means that there's a garbage collection issue. Now, for the people who don't use Java or garbage collected languages such as Java, you may not know this, but when the garbage, you don't really have any control over when the garbage collecting is going to take place. And that means that especially if you have a large amount of data that needs to be collected, or a lot of garbage that needs to be collected, this can actually really impact your main thread basically, or the thread that is handling the connection. This is something that games developers learn, for example, when they use Java for some certain things, that you might have a game that runs and all of a sudden for a few seconds it just stops, or a fraction of a second it stops, and then it keeps going, and then it stops, and then it keeps going, and that's the garbage collector. So basically we are faced with this kind of issue where we now have to figure that out, right? How do you manage this? Because hey, we can't just rewrite the whole system in something different. So the first approach is, of course, to as part of Java 9, we're going to have G1 as the parallel, their parallel garbage collector to be the default. So we thought, all right, let's try that and see if that solves the problem for us, because we can't have this stop the world type of thing going on when we're doing such a heavy computation. And said and done, we tried it, and it did improve the percentage a little bit. I was actually surprised. I thought it would have solved the whole issue, but then again, I'm not an expert in garbage collection. But we're still not where we need to be. So now the next approach becomes to think about, all right, how can we maybe restructure the algorithm or the call itself so that it doesn't produce so much garbage? That's also a feasible approach. And then I had this moment where I kind of started thinking, I know that it's too early, I'm not going to say anything until we are certain that we need a separate solution, but I'm going to look into it. Because this, to me, sounds like one of those perfect situations where you want to have this algorithm written in a language that can manage ideally both parallel processing, so we can run multiple threads in an easy manner because it's a heavy computation, but we also want we want memory control. We don't want a garbage collector because it's going to cause us a lot of problems and issues. Now, what language do I know that can probably do this, or would probably be a good fit for this? Well, Rust. Well, and let's be honest here, C and C++ as well, but if I have the choice between these three languages for a fresh project, I would prefer working in Rust. So I'm going to have a little bit of an experiment to see if I can simulate this sort of issue and just isolate the problem area, because I know where the problem area is in the code base. and see if Rust can help me out with this. Because, as I said, the core issue here is that we have a garbage collector, and that's something to take away from this. That there are certain situations where Java, and like I've been saying that Java is a really great choice for a lot of reasons, and it is a good choice for a lot of reasons. In this case, it's Scala, but the same applies for C# and so forth, or .NET, whatever you like to call it. But there are certain situations where that's simply not good enough, when performance actually matters. This is one such occasion. Now remember, we're not just, oh shit, we have a problem with garbage collecting, let's throw a complete new rewrite into it. We're trying some stuff out first and foremost, because it would be very beneficial for the company if we could stick with Scala and just keep ourselves on the JVM, because it brings a lot of overhead and maintenance and other complexity to rewrite something in a system level language or something of that nature. But at least this is a situation where it could be feasible that this would be a good solution. And that's also what Rust, the community of Rust, actually kind of advocates, to not do a complete rewrite of something, but to find those specific areas where you actually need the performance and the memory management and all of that good stuff, and create a service for it. This would be a really interesting experiment to see if we could to use this for. So we'll see how it works out, and hopefully I'll get to do some production level Rust code. Have a great day.